Alright, I'm going to start up on this. We'll do as much as we can. If we can get the whole chapter done before the break, next break, fine. And if we can't, that's also fine. So I am on page 351 of the text, using classes and objects. And again, much of the material in here, you'll say, didn't we just go over that? Yes. Alright. Some of it's new. If you take a look at the objectives here, I'm not going to read them to you, but if you look at the objectives that are shown on the screen or in your book, what you're going to notice is some of these we have not talked about yet. All right? We will talk about them in this chapter. So the author here on page 352 tries to kind of sell you on the fact that you do a lot of this stuff whether you realize it or not. All right, again, I don't want to sit and read stuff to you. I'm not going to. But they do mention classes are the building blocks of object-oriented programming. All right? And the author says here, you know the difference between a double and an int32, etc. Those are all classes. Those are examples of numeric classes. All right? As far as some of these class concepts, the reason I thought it wouldn't be a bad idea to go over that other one first is I think this will help. And some of this stuff will be asked again when you take your Chapter 9 written test. All right, so if we look on here, classes are application programs with a main method. So you still need a main somewhere because main is your point of entry. All right, it's the first method that gets called. As it says, classes from which you instantiate objects. When you create an object from a class, it's called instantiating an object or an object instantiation. All right. So as it says, every object is an instance of a class. Every object is an instance of a more general class. All right. And you can, you literally, when you start doing this, what a lot of companies do is they make what are called hierarchies of classes. Sometimes these hierarchies they may be hundreds of levels deep, depending on the complexity of what the company does for a living. The data components of a class, it says, that differ from one another. All right, they're called instance variables. Going back to the example I gave you before. Again, it's like if I said James' height versus Chase's height versus John's height, etc. They could all be different. They're all heights. They're all based on the number of feet and number of inches or the total number of inches you are, but they could be different. All right, those are instance variables that are also referred to as fields. All right. Methods associated with objects are called instance methods. What you're going to see in just a couple minutes is virtually all the time when you create these instance variables, you'll have what are called getters and setters, or get methods and set methods. The get and the set can be different for each object, and typically are. So, creating a class from which objects can be instantiated. So this is where the author is kind of starting with this. All right, and again, it is on page 354. All right. So the author says it can start with an optional class modifier. Normally it's not optional. All right, and they show you this same chart. You saw this just a few minutes ago. Public versus protected versus internal versus private. All right. You can have private classes. You can have private classes with public methods. You typically wouldn't do that, but you can do that. As it says, if you don't explicitly include one of these, if you don't specifically say public or private or protected, it defaults to internal. All right, and again, that's not usually considered to be a good practice. Now, if you look on page 355, because the author's starting real slow, the author's saying here, let's create a class called employee. Well, if you notice on the top of the page, that's what it is. Class employee. Okay. Typically, if you wanted to be able to use it throughout an application, it would be public class employee, but that's all she's written here. Class is a keyword. Employee is the name of the class. Classes should always start with a capital letter. All right. And then the body of the class is what goes in between the curly braces. So again, if we look a little further down on 355, you'll notice now we've got an employee class that has an ID number. That ID number could be a social security number, could be an employee number, could be a lot of different things. All right. But as the author says, right underneath figure 9.2, a little more than half down on page 355, using private fields within classes is an example of this encapsulation or information hiding. All right, and it's considered the right way of doing things. Again, as I've done, the author says you do that in your real life anyway, whether you realize it or not. All right, in contrast to a class's private data fields, most instance methods are not private, rather they are public. You already saw this. So as we turn up to page 356, notice what we have here. We've got an employee class. That employee class consists of one private instance variable and one public method. All right. And again, as they mentioned, if you look in here, the word static is never used. You don't have to do that when you're working with classes, unless you want to create a special kind of variable or a special kind of method. We'll get into that in a bit. As it says, the keyword static is used for class-wide methods, but not for instance methods. Kind of what we saw before with that person count that we looked at a few minutes ago. All right. So the author says this is not a program. If you put in just this, come on. If you put in just that you see on the screen right now, and you ran the program, it wouldn't run. There's no main. All right. There's a class a declaration right there, but there's no main to actually run the class. All right. They give you some verbiage here on the top of page 357, and they talk about composition. Okay. And again, these aren't my words, but let's assume that I create a class that's called clock. Everybody with me? I'm creating a class called clock. And I'm going to say it's got three different things in it: hours, minutes, and seconds. And then later on, I decide, hey, you know what? I want to create a class called alarm clock. Wouldn't it make sense to not start from scratch? But wouldn't it make sense if I already had a clock class to use that in an alarm clock class? In other words, I could say that an alarm clock class is composed of or has a clock in it. On the other hand, when you use inheritance, which is in the next chapter, in chapter 10, rather than a has-a relationship like they show there, you have what's called an is-a relationship. All right? And again, I don't want to go into it in any more depth than that until the next chapter. So, creating objects on the bottom of page 357. Declaring the class does not create any objects. A class, again, is a blueprint of what an object will look like. So they show this if we turn up to page, actually it won't be till 359, but that's fine. This is how you create an object, though. The name of the object, of the class type, the name of the object, and you can either do it over 2 lines, like they show right here, or over 1 line, like they show right here. So either 2 lines, as shown on the top of 358, or 1 line, shown a little lower on there. The key thing to realize about a class, and it may not make any sense to you, but occasionally what could happen is I create a class, and now I do a write line, and I put the name of the class in there. Are you with me? So I create a class, and it's called person. Then in my next line, I put a write line that says write line person. Or even if I create an object, I say write line Luke. What's going to typically print is an address in memory. Because what happens is when you create a class is called a reference type. A class could be humongous. It could hold hundreds of things. And the chances of it all being in the same place in memory, one after the other, are almost none. So when you create a class, what you end up storing in memory is the address of where in memory the beginning of that class is. And that's what they're saying right here, which makes it a reference type. We talked about reference types and value types earlier. It would make it a reference type. Middle of page 359, after an object has been instantiated or created, its non-static public members can be accessed using the name of the object, a dot, and the public members' identifiers. We already saw an example or some examples of that earlier. All right? So this is what a main would look like for what they showed before. Employee, my assistant, equal new employee. And if you look on the screen, it's important that you at least realize what these things mean. Name of a class, name of an object, equals new type of class. That's instantiating or creating an employee object named my assistant. After you create that, then you can use the message. My assistant, so the name of the object, dot, then the name of the method. And that's exactly what the author is trying to show there on the bottom of page 359. If you run that, then it's going to look like this. Welcome from employee number 0. How can I help you? All right. And where they get that from? Earlier, they showed what would be inside of the class. Passing objects to methods, rather. You can pass an entire object to a method. All right. So notice this: display employee data, string order, etc. You can pass as much of something or as little of something as you want to or need to pass in order to get it to work. So right here where they say emp, in this example down here, get rid of this, where this says emp, come on, all right, that would be, the first time it would be a worker, the next time it would be another worker. All right. All right, here's where it breaks, and it's different really from what we talked about in the last chapter, or in the PDF I showed you. And in here, starting on the bottom of page 361, the author mentions creating properties. And what a property is it's a piece of data that's associated with a class. All right. So if every employee had something called ID number, then ID number would be a property. And most of the time when you use properties like this, you are going to have what are called gets and sets. Now, I'm going to show you something, and you might look at it and go, do we need to know this? The answer is no, but I want to show you a quick shortcut in here. All right? So I'm going to come in, and I'm going to start up a new session of Visual Studio. And I'm going to come in, and first I'm going to kind of do it the simple way as we were shown before, but I'm going to just create this right here, and I'm going to call it Person Demo. Now, if you would, please look up on the screen, because this is going to be something you haven't seen before. All right? If I type in here, Person Demo, then automatically the name of this particular project is Person Demo. That makes sense. But that's also the name of my solution. I may not always want it to be that way. So what I'm telling you is if I have a bunch of classes, this might be called Person Demo, or maybe this one is just called Person, and I call this one Person Demo. So notice that the name of the project and the name of the solution are different. So when I click OK, if you look over here, at the top, you see, or you will see in a minute, the name of the solution, which is Person Demo. Then underneath that, you see the name of the project, which is Person. Why does that matter? It does because I can right mouse click on this thing that says Person Demo, and I can choose Add, and I can put another project in there. So one solution can contain multiple projects. We haven't done that yet, but it's totally legit to do that. All right? All right. I just wanted to show that to you in the way that that's set up. So I'm going to come in here, and I'm going to close this, and I'm going to come back in here, and I'm going to, let's see, so it probably created a person object here, which is actually fine. Let's just do it. But I'm going to come in here, and I'm going to say File, New, Project, and I'm just going to make it a console app, because there's just going to be code in there. All right? And I'm going to try typing in Person again, and I want to see if it's going to give me an error. And the solution name will be Persons. All right? So it's a console app. All right? And I'm going to click OK. Either when we look at this, you're going to be more confused, or you're going to be like, okay, now it makes a little bit of sense. That's my hope, is that's what you're going to think. All right? So I'm going to come up here, and kind of the way they did it in the PDF I just showed you, I'm going to type in here, class, person, okay? And in here I'm going to have int height, int weight, string, eye color, string, hair color. All right? So that's saying that every person has this stuff. And then I'm going to come in here and I'm going to say person, and notice it automatically capitalized it. All right? So I'm going to say person Jeff equals new person. All right? Now, what I should do is I should come in and make these public or private or whatever. All right? So I'm going to come in here and I'm going to say private. In fact, before I do that, what if I come in here now and I say Jeff dot? All right? Doesn't show anything. Okay, so it still doesn't recognize it. But notice if I came through here and I said public int weight, now if I say Jeff dot, can you see how weight is now accessible in here? Because it's public. It's what you don't want to do. All right? So really, I'd want to come in here, and I'd want to say private, int weight, private, string eye color, private, string hair color, and I guess somehow we removed the height, but so now I've got that. So when I come in here and I say Jeff dot down here, it doesn't show me any of them. But if I come through here now and I say public void set height, all right, and I'm supposing that I need a height in here to set height. Now I should be able to come in here because this is public. And notice if I say Jeff dot, all right, and I say, well, you may or may not have noticed it. There it is. Set height is right there. It recognizes it because it's public. And I guess I really should have made that a capital S. All right. So when I come in and say Jeff dot, and I type in set, it recognizes that. Also notice it lets me know, hey, it expects there to be an integer in there. All right. So if I come through there and put in 72. All right. Now what I've done is I've just created a Jeff object right here, and I set its height. Does that make sense? Yes? No? All right. I can put stuff in here. For instance, I might want to say something like if height is less than, I don't know, 12, less than a foot, or height is greater than, I don't know, 96. I don't think anybody's more than 8 feet tall. All right, then I could, whoops, and I could come in and say, I'm just going to set it to some default height. Height equals 60. Else, and I'm going to say I put in a valid height, so accept that. What I want you to understand, though, is if you look up on the screen, I can put logic in there if I want to or need to do it. All right. I don't have to check to make sure that what I passed in, I don't have to do an isNumeric check. Why? Because I've already set up there that it's an int. If I try passing in something that's not an int, I'm going to get an error message. If I come down here and I say Jeff.setHeight and I put in hello, I'm going to get an error message right there. The program you'll just poop out right there. It has to be a number. However, if I do come through here and I put in 1,000, now it'll come through here and say, is it less than 12? No. Is it greater than 96? Yes. So it'll set the height to a reasonable value. All right, rather than saying a person is 80-some feet tall. All right. That's what we looked at so far. But if you go and turn up in your book, please, to page 362, quite often when you do these, you don't do them like this. You create what are called getters and setters. And I'm going to show you what's supposed to be a fast way to create these. First, I'm going to show you a slow way, then what's considered to be a fast way to create them. So I'm going to come in here and I'm going to say public, and notice that's called height. If I want to create getters and setters, I have to call it height, but that has to be a capital H. So, like that. Then in here, and yeah, I'll get an error until I get it all done. Why it's goofing up with this, but it is. All right. So now if I can come in here and say, for example, get, and I can say return height. And I can say set, and I can come in here and say height equal value. All right, trying to figure out right now why I'm getting all these errors, but I am. So why does it give me these? The name get does not exist in the current context. Yes, it does. There we go. All right, and that's just value, not value type. That's why that's the error. All right, so what is this doing? Notice these are all blue. This one's gray. That one has basically been replaced with this. What this is saying right here is, okay, I can write a getter. What does that do? That just says if somebody asks for the height, return the height. Then I can write a setter. What does that do? That assumes I'm passing a height in, and that height becomes the keyword value. And I set the height to whatever I passed in. Now, does that make sense? If you haven't read the chapter, it probably makes no sense. All right, yes? Are you talking about right in here? Is that what you mean?
No, I mean like when you create a new person, you set like
that's what we're going to move to. Yeah. That'll be when we talk constructors and overloaded constructors. Yes, you can. But sometimes you don't know what that is. If I just hired you, and if it has something in there like salary, I might not know what your salary is yet. All right. Now, there's a faster way to do this. All right. And that is, you can come in here and you can just type in, what is it? You can type in the word prop and tab. Of course, it doesn't work. P-R-O-P. Well, there's a shortcut. I guess I'm not remembering how to do it right now. Our book is going to show it to us in just a bit. All right. But what I showed you, if you look up on the screen here and you look on figure 9.8, which is on the bottom of page 362, it's pretty much what I just did for you when I used height. All right. So if you didn't understand that, you're going to have to read this. All right. This isn't a threat, but what we're going to do is we're going to build an employee class. All right. And then after we build the employee class, we're going to say, okay, now you work for this company, and this company has 3 different types of employees. So we're going to have an employee base class, and then we'll have classes under it. You're either an hourly employee, or you're a commission or salary employee, or you're a piecework employee. So we'll create those. And then hopefully you'll start to see how it all fits together. Then when you do a test, it won't be employee, but you'll be creating your own class. For Chapter 9, then for Chapter 10, you will be creating subclasses or child classes of that. And then for Chapter 11, you'll be adding what are called exceptions in. All right? Now, these are typically called getters. Start with the word get. These are typically called setters that start with the word set. And as mentioned on page 362, they tell you exactly what a getter and a setter are. All right? If I would have come in here where I just showed you this, okay, this back the way we had it. If we go back to this, if I decide for whatever reason I'm not going to have this, you see what I'm doing? See, I've got a getter and setter. Now I remove the setter. Everybody see that? Now it's read only. I don't have the ability to set something. It's read-only. It's almost like it's a constant. What you don't do very often, but you can do, is I can also remove this. Now it's write only. All right, and they do explain that in the book. One of my charges, one of my goals, is to make this, give it to you where it's complex enough that you come up with an application that's usable. You can put onto your portfolio, and somebody will look at it and go, oh yeah, Luke understands object-oriented programming. Yet that's not so over the top that you don't understand what the heck you're doing. Maybe you can tell, but this is always, and I'm being very sarcastic here, my favorite lectures to give, because you all have the same look on your face. So probably the worst day to give this is right after you just had a day off. All right, but that's the way it worked. All right. So if you look on the screen here, what do they have? Employee, my chef equal new employee. Then you look at this and you're saying, well, you said we can't do this. .id number. Yeah, you can, because that was set up as being public. All right. And so was that method. Like I said, some of the examples that she puts in here, I was more confused after I read her examples than before I looked at them. All right. Now, I promised, but I screwed it up. Using that tab thing, which I'm going to show you, those are what are called auto-implemented properties. All right. So let's see if we can get those in here. On page 366 of your text, so on page 366, the author says, although you can include any number of custom statements within a get and a set, sometimes you don't want to include anything. You just want them literally to look like this. Public int followed by the name, and then just get and just set. All right, that's pretty small when you look at it. Do you have to put the curly braces on the same line as the get and on the same line as the set? No. You can put them on multiple lines if it's easier for you to read. Or you can put them exactly like that. A property written like this is called an auto-implemented property or an automatic property. All right. They show an example right here. And if you look at it, there's basically no code in here. There's no code in here other than a get or a set, which means that if I ask for an ID number, that gets called, which gives me the ID number. If I try to set an ID number, that gets called. So I set the ID number. All right. And again, I'm not saying, hey, does that totally make sense? It may make no sense. All right. Now, I would suggest if we finish today and you're like, I just listened to him, he talked for 2 hours, and I don't have a flipping clue as to what he said. None of it made any sense to me. I would start by doing this you do project that's on pages 368, 369, 370, and 371, because as our author often does, she comes in here and she says, in this section, I'm going to create a student class, and I'm going to make objects from it. The student class will have an ID number, a last name, and a grade point average. And it'll have properties that get and set each of these. It'll also show you how to pass an entire object to a method. So again, she says start a new project. Okay. Right up above or below the main, put in this code that's here. All right, then add these constants. Add the auto implement. Notice she has spread them out over multiple lines here. All right. Then notice for the grade point average, here she's actually putting in some code. Why? Because she's trying to make sure that the GPA you put in is between 0 and 4. If it is, it'll be accepted, and if not, it won't be accepted. So then she creates some students, and she displays their information. And again, I'm not saying to you, hey, does all this totally make sense? But it's a really good starting place right here, is to go through this example. All right? This is almost what we're going to end up doing tomorrow morning together.
Why doesn't she have the private or public for the method?
She does have the private, or she's, why does she?
Static, static void main instead of like what we're going over in the beginning, private and public.
What are you talking about? Are you talking about on number 9 there on page 370? Or are you talking about something else?
Number 9 and number 7.
Well, that particular display, that's inside of main.
Okay.
That's why. Since it's dealing right with main, it needs static. All right. All right. And on the bottom of 371, the author says here, let's talk a little bit more about public and private. Again, most of the time, as mentioned, the class's data fields are private and its methods are public. All right? It says novice programmers might want to make a data field public to make it easier on themselves, but it violates a basic principle of object-oriented programming, which says data should be hidden when possible and access to it should be controlled by getters and setters. All right? Well, then the author comes out and says, yeah, but sometimes, and if you look at this example on the top of 372, there's a constant called motto, our carpets are quality made. And as I told you before, there's not a problem with taking and making a constant public. In fact, you are encouraged to make your constants public. All right, let's go a little further, and we'll take another break. I'm up to page 375, and it says, understand the this reference. And understanding this, that starts on 375, and it goes to 376, 377, and 378, might be the hardest part of the chapter. All right? This kind of means whatever is active, for lack of better words. All right? It's a key word. When you put in this, it'll typically change colors when you're working on it in a program. If I come through here, all right, and I come in here and I say this dot, notice how it changed to blue. All right, it is a key word. So the author says when you create a class, only one copy of the class code is stored in memory. But you might create thousands of objects from that class. When you create each object, it says you provide for storage for each object's instance variables. You already saw that. I mentioned to you if I created 12 persons, one for each one of you would have your own height, your own weight, etc. I also mentioned to you that if you do this, all right, and you want to be sure what you're working with if you don't want the software to become confused. So notice on here we've got return this dot title equal value. Do you need that? They didn't show it before. Probably at least half the time, if not more, when you use the keyword this, you don't have to. If you don't use it, it's implied. But there are many programmers that always use the keyword this whenever they can, basically. All right. And the author has got, I think at least, a pretty good explanation here of what this is all involved with on page 377. And again, I can't say this too many times. You'd have to go back and read the chapter. All right. I always find this interesting, and none of you have done this. I'm not saying you have, but I remember in the past many times people saying, you know, I got an A in the class, and other than like when we looked at a test, you know, study for a test, or I never really read anything. I never read a chapter I'm like, if that's supposed to make me feel good, it doesn't. There's no way I can replace a book. All right, I'm giving you in an hour or 2 hours what would take you at least that to read, probably, and understand. All right, on the bottom of 378, they talk about constructors. Notice, a constructor is a method that's got the same name as the class that's automatically called when you create the class. Look at what it does. When you asked that question before, Christian, you know what I thought you were saying was, why at the top of the program, why didn't you say height equals 0, you know, etc. Why? And you don't have, I know that's not what you asked, but what I'm saying is, had you asked, I would have told you, you don't have to because it's automatically done for you. That's why you don't have to do that when you work with classes. A lot of stuff is automatically defaulted to values for you. Sometimes, though, that's not what you want. That's why a constructor is just an overloaded method. So when you call it, you can either pass it nothing, or you can pass it something. So notice here we're calling, when we create an employee, we're calling this. It automatically sets their pay rate to $9.99. But here, we're passing in a pay rate. Now, you might want to do something there that, again, says if the pay rate that you pass in is less than something or greater than something, you set it to $9.99. All right? But again, you can overload constructors. And that's what they start talking about on the bottom of 380. And then they show you examples right here. Notice, there's the constructor once passing in nothing. There's the constructor again passing in just an int for the ID. There's a constructor again passing in the ID and passing in the salary. And there's the ID one more time passing in a code. Every one of those signatures, or every time what you see in the parens are different, so that's totally legal. Same stuff that we talked about in a previous chapter. Once you get a little more versed with this, and it makes a little more sense to you, then you notice how you can also use what are called object initializers. I'm not going to go over that because it's really hard, and I'm trying not to confuse you. All right. You can read that section on your own, 382 and 383. All right, I'm not going to go over those because, like I said, it's not my goal to confuse you. Read only, I've already mentioned this with read only. Okay, you don't put a set in there. And the author's saying, even though you can put the word read only here, see that? Private read only int ID number, or you can just leave the set off. If you put the word read only in there and you add a set, the word for that would be stupid. You're saying you're not going to be allowed to set it, but yet you're giving them a set method. You shouldn't do that. I don't typically even use read only. What I do is I just remove the set method, which automatically makes it read only. All right. Again, look on the screen, please. Starting on 385. Now there's another example on 385 and 386, just 2 pages long, where the author again says, in these steps, we'll show you overloaded constructors. It's working, I believe, with the same example you started with earlier. So again, I would strongly encourage you to take a look at that. The bottom of 386 and going on says there's an object initializer. All right, and notice what it says here. An object initializer allows you to assign values to any accessible members or properties of a class when you create it without calling a constructor, without using parameters. All right? Again, I mentioned this term to you before. Many people who consider themselves object-oriented purists say, you shouldn't do this. This is a really bad practice. But they let you do it anyway. But it's one of those things, just because they let you do it doesn't mean that you should do it. All right, I'll just leave it at that. All right. You turn up to page 390. Like I said, this is as dry as it gets in here. It's 10:02. Let's come back. Let's make it 10 minutes. I'm going to start up at 10:13, talking about overloading operators.